In this video, we will be discussing ways to solve quadratic equations. This section correlates to the free college algebra textbook on OpenStax. So the first few we're going to solve by factoring. So first, let me just point out that you know that this is a quadratic because the highest exponent on a variable is a 2. So that is a quadratic equation. So if we're going to solve by factoring, that means we want to have everything on the left-hand side set equal to 0. Then we're going to factor. So this is a trinomial. It has 3 terms. So we want to figure out what multiplies to get negative 21 and what adds to get 4. So if we look at our choices, we will use 3 and 7. We need a negative 21, so one of them needs to be negative. And if the 3 is negative, then they will add together to get a positive 4. Okay, so we're going to factor this one into x minus 3, x plus 4. It's equal to 0, so we still have the equation. We need to bring that down. Remember that when you are solving by factoring, we have what's called the zero factor property. The zero factor property states that if you have a product set equal to 0, so if you know that a times b is equal to 0, then you know that either a is 0 or b is 0, or they're both 0. And that's because the only way to get 0 when you multiply is to multiply by 0. So we're going to take that idea and use it for this first example. We have x minus 3 times, so remember that this is a times, x plus 4. So that means I have 2 things multiplied together set equal to 0. So that means one of these things must be 0, or they could both be 0. So we're going to set each factor equal to 0 separately, and then solve for each simplified equation. So you can see when we break it apart, now we just have linear equations that we can solve. To solve for the first one, we just need to add 3 to both sides, and we'll get x equals 3. For the second one, we just subtract 4 from both sides, and we get x equals negative 4. So here, our 2 solutions are 3 and negative 4. All right, for the second one, we're going to be factoring here as well. The first thing I notice is that all 3 terms have a factor in common. I can divide out a 4 from all of those. So what I want to do here is divide out a 4, and that would leave me x squared minus 3x plus 2 is equal to 0. And then I can continue factoring what's in parentheses. So we'll have 4, and this will be x and x. What multiplies to get 2 and adds to get 3. So if we use a negative 2 and a negative 1, that would multiply to get a positive 2, but it would add to get a negative 3. So this is now fully factored. Here we have 3 factors. So 4 is a factor. If I set that equal to 0, there's no variable here, so that does not lead to a solution. The next factor I have is x minus 2. There is a variable there, so this one will lead to a solution. This will be x equals 2. And then the third factor is x minus 1. That also has a variable, so when I solve for x there, I will get x equals 1. So my 2 solutions are 2 and 1. All right, number 3. Same directions, we want to solve by factoring. So if we're going to factor, we need everything to be on the same side and have it set equal to 0. So I'm going to subtract 5x from both sides. So I'll have 4x squared minus 5x is equal to 0. And now we want to factor. So we can see that both of these terms have an x in common. So I want to factor out an x. And when I do, I will have 4x minus 5 left. Okay, so now I have two factors. X by itself is a factor, so I need to set that equal to 0. Notice that I do have a variable here, right? This is x equals 0. So this is one solution. If you compare that to number 2, I had 4 equals 0. That did not lead to a solution because there was no variable. But in number 3, the thing out front is an x, so that will lead to a solution. And then I have 4x minus 5 as my second factor. It does have a variable in it, so it will lead to a solution. So I add 5 to both sides and get 4x equals 5. Divide by 4. So x equals 5/4. So here my two solutions are 0 and 5/4. All right, so the next method we're going to talk about is the square root property. So if you're going to solve by the square root property, what you want to do is make sure everything on one side of the equation is squared or raised to the second power. And then to undo that, you just take the square root of both sides. So in number 4, we have x squared on the left. So to undo that square, I'm going to take the square root of both sides. Now, it's important when you introduce a square root into an equation where there wasn't one before, you have to put plus or minus. And that's because when you square it to get back to the original equation, it's going to make it positive either way. So you want to put that plus or minus in. So on the left-hand side, the square and the square root, they undo each other. So you're just left with an x. And on the right-hand side, you have plus or minus. The square root of 36 is 6. So here your two answers are 6 and negative 6. Okay, this is kind of the lazy way to write it, plus or minus 6. But you could also write them as separate numbers. Okay, but either way, just know that you have two answers there. Remember that since your highest exponent is 2, you're looking for two solutions. Sometimes it doesn't look like you have two solutions because something might be repeated. But in general, the exponent tells you how many solutions you're looking for. Number 5, we're going to do this the same way. Notice that x squared is by itself on the left-hand side, and there's not an x on the right-hand side. So that's another important thing. This won't work if you have an x on the right-hand side. So x squared, we're going to take the square root of both sides. Don't forget to put plus or minus. On the left-hand side, the square root and the square undo each other. And then on the right-hand side, we have plus or minus. Remember, the negative under the radical comes out as an I. So this is going to be an I. And then the square root of 225 is 15. So this will be 15I. Again, you have two answers. One answer is 15I, and the other answer is negative 15I. All right, number 6. This is still the square root property because you only have an x on the left, and the whole left-hand side is squared, even though it's not just an x. So since everything on the left-hand side is squared, we can go ahead and undo the square by taking the square root of both sides. If we do that, the square root undoes the square, so we just have x minus 3 on the left. And on the right, we have plus or minus the square root of 7. That won't reduce, so we're just going to leave it in that form. And now we want to continue by trying to get the x by itself. So we can undo the minus 3 by adding 3 to both sides. So that'll give us x equals. Here, remember that the 3, this negative 3, and the square root of 7, those are not like terms because one is under a radical and one is not. So you want to take what you just brought over. Whoops, and I don't know why I have a minus. That should be a plus. So we'll have a positive 3 plus or minus the square root of 7. It's really good form to put the plus or minus last. So put the 3 first and then put the plus or minus the square root of 7. Again, you can see you have two answers. One answer is 3 plus the square root of 7. The other answer is 3 minus the square root of 7. Okay, let's look at number 7. So if I'm comparing number 6 and number 7, number 6, we had the whole left-hand side was in parentheses squared. Number 7, I hope you see the difference. Here, the difference is you have this plus 8 on the same side of the equal sign as the square. So we really need that whole side to be squared. That 8 is messing it up. So what we want to do is get rid of that 8 from that side. So we're going to subtract 8 from both sides. Okay. This will give us x plus 5 squared equals -6. Now you can see that the whole left-hand side is squared. So at this point, we can use the square root property, take the square root of both sides. So we get x plus 5 is equal to plus or minus. The negative will come out of the radical as an I. The 6 cannot simplify down, so it's going to be I squared root of 6. And then to get rid of the 5, we're going to subtract 5 from both sides. So we would get x equals -5 plus or minus I squared root of 6. So those are several examples of how to use the square root property given different starting points. Okay, number 8. We're going to solve this one by completing the square. So in this one, what you want to do is get everything with an x on the left-hand side and anything without an x, so the constant in this case, to the right. So to do that, the first thing I want to do is subtract 6 from both sides. So that will leave me x squared minus 8x on the left side, and we'll have -6 on the right-hand side. Now, what I want to happen is I want the left-hand side to be factorable. I want to be able to factor. If you look at the original problem, I can't figure out two things to multiply to get 6 and add to get -8. So it's not factorable. I want to make it be factorable. So what I'm going to do is I'm going to add some number to the left-hand side so that it is factorable. In order to do that, I have to add something to the other side as well. As long as I'm keeping it balanced, it's okay to add something to the equation. Okay, so now to figure out how or what number we're going to plug into the blank. So what you want to do is you want to take the number in front of the x. So in this case, you have -8, and you always divide by 2, then square it. So -8 divided by 2 is -4, and then we're going to square that, and that'll give us a positive 16. That is what we put in the blanks. Since we're squaring the number, it'll always be a plus blank, okay? And so now we have created something on the left-hand side that is factorable. So what multiplies to get 16 and adds to get -8? So you will see that what works is 4 and 4, and moreover, they both have to be negative. So -4 times -4 is positive 16, and then -4 plus -4 is -8. So you have the same factor twice. So this is going to factor into x minus 4 squared. This sign will always match this sign, and this number will always be the square root of the number from the blank. That's always how it works out when you factor it. And then on the right-hand side, we just combine like terms. So -6 plus 16 is 10. Okay, now look, this is now set up to where we can use the square root property. So the completing the square part, so let's see, this is the completing the square part. Okay. All you're doing is setting up your problem so that you can use the square root property. This is the only new thing we're adding on. Now we're doing the square root property, which is what we did in the previous procedure. So we're going to square root both sides, put plus or minus. So we'll have x minus 4 is equal to plus or minus the square root of 10, which can't simplify. Add 4 to both sides to get the x by itself. So we get x equals 4 plus or minus the square root of 10. And those are our two solutions. Okay, so let's try the next completing the square. So number 9 has the same directions, complete the square. First thing, you want to get the x's on the left and the constants on the right. So we're going to move the -3 over by adding. So x squared plus 4x is equal to 3. Remember, for completing the square, you want to be able to fill in the blank. All right, so that's the first step. The second step in completing the square is to take the number in front of the x, divide it by 2, and square it. So 4 divided by 2 is 2, squared is 4. So I'm going to put 4 in both of the blanks. Okay, now the third step in completing the square is to factor the left-hand side. It's always a parentheses squared. It's always the variable here. This sign will match, and this is the square root of 4, so 2. And then you combine like terms on the right. Okay, we've just completed the square. Now we're going to use the square root property to finish this out. So the square root of both sides, plus or minus. So we'll get x plus 2 is equal to plus or minus the square root of 7. And then subtract 2 from both sides to get the x by itself. So x equals -2 plus or minus the square root of 7. And those are our two solutions. Now, completing the square is much more difficult if there's a number in front of the x squared other than 1. So in examples 8 and 9, we have a 1 in front. If you don't have a 1 in front, you probably will not choose to do completing the square. Okay, you would choose a different method. So complete the square would work every time. Quadratic formula also works every time. So the factoring method, you can't have that, you can't use that every time because not all equations are factorable. But for the quadratic equations, you can always use completing the square, and you can always use the quadratic formula. So here is the formula. You need to have this memorized. So here is the formula. You need to make sure you memorize this formula. This is to solve for x in a quadratic equation. So if we look at example 10, we have a, b, and c. So a is in front of x squared, b is in front of x, and c is the constant, and it's set equal to 0. So if your quadratic equation is written in this standard form, you can pick out a, b, and c, and then you just plug those letters in where they go in the formula. So let's look at this example. So we have the number in front of x squared is a. So a is 2. All right, the number in front of x is b. So b is -8. And then the number out here by itself, that's the constant. So c is -5. Okay, so now we have a, b, and c. The formula, which was given above, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So now we have our a, b, and c labeled. We're just going to substitute those in. So we have a -b. b is already negative. So a -8, or the opposite of -8, is a +8. Okay. Plus or minus the square root of b squared, so -8 squared, minus 4 times a, which is 2, times c, which is -5, all over 2 times a, so 2 times 2. All right, we're going to keep on simplifying. So we have 8 plus or minus the square root of 64. So that's a -8 squared. It's a +64. On the next part, be really careful here. The signs is where most people make their mistake. we have two negatives multiplied together. Those two negatives multiplied together is going to give us a plus. I always like to look at my signs first, write down my sign, and then just multiply the numbers. So 4 times 2 times 5 is 40. All over 2 times 2 is 4. Okay, I'm going to keep on simplifying as much as possible. So 8 plus or minus the square root. 64 plus 40 is 104 over 4. And now I need to see if I can reduce that 104 or simplify. So if I do the prime factor tree, I can divide it by 2, and then I would get 52. And then 52 is 4 and 13. And then 4 can break down into 2 times 2. And now I have all prime numbers. So I can see that here I have a pair of 2's. So a 2 will come out. And a 2 and a 13 are left without a pair. So those will stay under. So this would be 2 square root 26. So this will be 8 plus or minus 2 square root 26 over 4. Now, if you can reduce this, you're going to be looking for, it looks like a triangle, but what you're doing is you're simplifying the 4 out of each term. So on top you have two terms. You have the term before the plus and minus, and then you have the term after the plus or minus. You're looking at what's outside of the radical. You can't simplify the 26 with the 4 because the 26 is under the radical. The 4 is not. But what's outside the radical, you can reduce. So since everything that I've highlighted in green, this is all divisible by 2. We can divide out a 2 and simplify this a little bit more. So 8 divided by 2, 8 divided by 2 is 4. 2 divided by 2 is 1, and 4 divided by 2 is 2. So I'm simplifying. I will have 4 plus or minus square root 26. So the 1 does not have to be written. If there's nothing there, it's understood to be a 1 divided by 2. This is the answer. So you cannot simplify just the 4 and the 2 because there's nothing here to simplify with it. You have to be able to reduce from all three pieces or you cannot reduce. Okay, so don't make the mistake of reducing just the 4 and the 2. So this is a completely made up term, but what you're looking for is a triangle of reducibility. Yeah, and when these type of problems, you've got to have this triangle where you can reduce from all the terms. Okay. All right, let's look at number 11. So this is another one we want to solve with a quadratic formula. So first, let's identify our a, b, and c. So a is in front of x squared, so a would be 1. B is in front of x, so that would be 4. And c is the constant, so that would be 2. Now we're just going to plug all of this in. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, I've got it all substituted in. So now I'm going to start reducing. So negative 4 plus or minus the square root. 4 squared is 16. I only have one negative here. So this is going to be a minus. 4 times 1 times 2 is 8. All over 2 times 1 is 2. Continuing, I will have negative 4 plus or minus the square root of 8. 16 minus 8 is 8. All over 2. Need to look at the 8, see if I can take anything out, simplify it. So if I do that, I can see I have 2 times 4. 4 breaks down into 2 times 2. I have a pair of 2's and a leftover 2. So this will simplify. So negative 4 plus or minus 2 times the square root of 2 over 2. Now to see if I can reduce. Remember, you cannot reduce here because you don't have anything in front of the square root to reduce with it. Let's look here. You're looking for this triangle. Do I have things that can reduce for all of these? So I'm looking at the -4, the 2, the 2. All of those have a 2 in common. So I can divide them all by 2. If I do that, I will have -2, 1, 1. So since the denominator is 1, I don't have to write it as a fraction. So I'll end up with -2 plus or minus the square root of 2. And those are my two solutions. All right, so we've gone over the 4 ways to solve quadratic equations. Now we're going to look at the discriminant. I believe there are a few in your homework assignment with the discriminant information. So the discriminant is just the part under the radical from the quadratic formula. So under the radical is b squared minus 4ac. Whatever is under the square root is going to determine what type of solutions you will have. So remember, if you have, let's see, our examples here. So if b squared minus 4ac is 0, that means what's under the square root would be 0. You're going to have something plus or minus the square root of 0. Well, the square root of 0 is 0. So here you're only going to have one answer, okay? This next part is saying if what's under the radical is greater than 0. That means if it's positive. So if you have something like, and it's a perfect square. So for an example, it could be square root of 4. That's a positive number, and 4 is a perfect square in that it's just 2. That means you'll have 2 rational solutions. Okay, the next one is if what's under the radical is greater than 0, so still positive, but it's not a perfect square. So this might be the square root of 5. You can't just take the square root of that, right? So that is going to be 2 irrational solutions. And it's irrational because it's not a perfect square. Okay? And then the last one is if what's under the radical is less than 0, so that means it's negative. So let's say -4. That means it's a 2i. Because you'll have an I, that's where you get 2 complex solutions. Okay, so again, just to recap, if you're looking at the discriminant, you're going to solve just for this part, the b squared minus 4ac. And if you get 0, so if you get 0, then you have one rational solution. If you get a positive, so this means positive, perfect square, you have 2 rational solutions. If you get a positive non-perfect square, okay, you'll have 2 irrational solutions. And here, if you get a negative, it doesn't matter if it's a perfect square or not, if it's a negative, you'll get 2 complex solutions. Okay, so let's do some examples just to make sure we understand what's going on here. Let me leave this chart in view for at least the first couple. Okay, so all we want to do is use the discriminant. So the discriminant is b squared minus 4ac. Just like when we're doing the quadratic formula, a is 2, b is -6, and c is 7. We're just going to plug those in. So we'll have b squared, so -6 squared, minus 4 times a times c. All right, so -6 squared, that's 36. We have one negative, so that'll be minus. And then we have, let's see, 4 times 2 is 8, times 7 is 56. And so then if we subtract, we get -20. So what we want to do now is look at our answer. Here is our discriminant. This is our discriminant. Okay? I can't spell that, but that's supposed to be a discriminant. Notice that we have a negative. Here is that case. We have a negative, so that means we have two complex solutions. That is what we want to tell here. So we're not solving, we're just giving the nature of the solutions and how many. That's it. Two complex solutions because we got a negative. All right, let's look at the next one. We have A is 3, B is 5, C is -8. So if we do this procedure for this one, we have B squared, so 5 squared, minus 4AC. All right, so 5 squared is 25. We have two negatives, so we're going to get a plus. And then we have, let's see, 12 times 8, 16, so 96. So plus 96. So 2 and 12, looks like we'll get 121. Okay, so we have a positive, so that means we have two options. We either have two rational solutions or two irrational solutions. So then what we have to look at is 121 a perfect square or not? Well, yes, 121 is a perfect square because that's 11 times 11. So if this is a positive perfect square, we can go up here, see that's this case. So we have two rational solutions. That's because we got a positive, right? A positive 121, which has a perfect square, right? All right, 14, last one. So for this one, again, we have A is 2, B is -4, and C is 2. So we're going to do B squared minus 4AC. So -4 squared is 16. We have one negative. 4 times 2 is 8, times 2 is 16. 16 minus 16 is 0. Okay, we'll notice, if I go back to the chart, we got 0. So that's the very top one. We have one rational solution. So one rational solution, because we got a 0 for our discriminant. Okay. So for these problems, in order to answer these, you will need to have this chart memorized. So that is what you need to do for this part.